Dear students, welcome to s.mathguru classes. Last video we solved some problems about maximum and minimum of two variables. If we have three variables x, y, z, now how to solve this type of problem? So for this we consider method of Lagrange method of undetermined multipliers. For this we can solve. If three variables are given, x, y, z given, then we can solve this. Easily you can solve. So for this, first you have to find the derivation. Lagrange method of undetermined multipliers. Let f of x, y, z be a function of three variables x, y, z, and the variables be connected by the relation phi. F is a function, phi another function. F given x, y, z something, and phi also one given condition x, y, z in terms of x, y, z. So we get this one. Now this implies f of x, y, z to have stationary values, then we have, for stationary values we have del f del x equal to 0, del f del y equal to 0, del f del z equal to 0. We know for critical values we have first order derivatives are 0. F of x, y, z to have stationary values if this equal to 0, this equal to 0, this equal to 0. Now these are 0. If we write in this way, del f del x dx, del f del y dy, del f del z dz, then also we get 0, because these are 0 means we get this result also 0. This is number 2 we consider. We consider 2. By total differentiation, of 1, we get 1 is phi. If we using total differentiation formula, then we get del phi del x dx, del phi del y dy, del phi del z dz equal to 0. This is the total differentiation formula. This is number 3 we consider. So we consider 3. Now we multiplying this equation number 3 by lambda and adding with 2, we get multiplying 3 by lambda and adding to 2, we get what we get. If we multiplying this equation by lambda and adding with 2, then we get directly, I want to write, then we get del f del x lambda del phi del x dx, multiplying by lambda and adding with this dx common, lambda, we get this, plus del f del y lambda del phi del y dy, plus del f del z plus lambda del phi del z and dz, this equal to 0. So we multiplying this equation by lambda and adding with this and calculate this dx common, then we get lambda here this, and here also lambda dy common, we get this lambda dz common, we get this one. This equation will hold. This equation will hold if this equal to 0, this equal to 0, this equal to 0. Otherwise not possible. So if del f del x plus lambda del phi del x equal to 0, del f del y lambda del phi del y equal to 0, del f del z lambda del phi del z equal to 0. We get this is equation number 4, this one 5, this one 6. We get these are the equation. This will be hold if we get this. Now these are method of Lagrange multipliers. So this on solving 1, 4, 5, 1, 4, 5, 6, we can 4, 5, 6, we can find the values of x, y, z and lambda for which f of x, y, z has stationary values. So, solving these three equation and equation number 1 by the help of equation 1 and 3, 4, 5, we get the values of x, y, z and lambda. For getting this value, we get the stationary values, that means maximum and minimum values for this particular problem. So this is our condition. For solving some problems, we have to use this formula. No need to derive in this way. Directly we write this 3 formula. When one problem we get, by using this 3 formula, this is called Lagrange method. Lagrange method by Lagrange formula. Then we get these 3 equations. By the help of this 3 equations, we can solve any kinds of problem. Now let us consider one problem. Consider this problem. Find the maximum value of x² plus y² plus z² subject to the condition x, y, z equal to a cube. So this one given. So first one, you consider f. Let f of x, y, z equal to x² plus y² plus z². This is number 1 you consider, and phi of x, y, z this equal to x, y, z minus a cube. This equal to 0. Number 2 we consider. This one taking left hand side, we get phi of x, y, z minus a cube. So we get f and phi. We use the Lagrange method. By Lagrange method, we have what we have using the formula. We have del f del x lambda del phi del x equal to 0, del f del y lambda del phi del y equal to 0, del f del z lambda del phi del z equal to 0. We get these are Lagrange method. Now putting the values, this implies del x f. F means this one, x square plus y square plus z square, and lambda del x of phi. Phi means xyz minus a cube, this equal to 0. And this implies this will be twice x plus 0 plus lambda, this is yz minus 0, this equal to 0. So what we get, twice x plus lambda yz, this equal to 0. This is number 3 we consider. So by putting the value of f and phi, we get this equation. Now here we putting del y f x square plus y square plus z square plus lambda del y phi xyz minus a cube, this equal to 0. We get this one. Now if we solving this is 0 plus twice y plus 0, because we differentiate partially with respect to y, and this one lambda xz, y is 1 minus 0, this equal to 0. So this implies 2y lambda xz, this equal to 0. This is number 4 we consider. And the last one we get del f del z lambda del phi del z. Del z f x square plus y square plus z square plus lambda del z xyz minus a cube equal to 0. This implies 0 plus twice z lambda xy into 1 minus this one minus 0, this, and this is within bracket, we get this one 0, and here also yz, this, if we differentiate it, yz x is 1 and this. Now this implies we get twice z plus lambda xy equal to 0, this is number 5. We get these three equation, 3, 4, 5, these three equation. Now we multiplying equation number 3 multiplying by x. This is equation number 3, we multiplying by x, then we get 2x square plus lambda xyz equal to 0. This is number we consider 6. And equation number 4 we multiplying by y. 4 into y. This implies 2y square plus lambda xyz equal to 0. This is number 7 we get. And equation number 5 we multiplying by z. This implies 2z square lambda xyz, this equal to 0. This is number 8 we get. We get another 3 equation. Now we subtract these 2. If we subtract this and this lambda will be cancelled. If we subtract this and this, we get lambda, this xyz cancel. So 6 minus 7. Now 6 minus 7 implies. Then we get this cancel, we get 2x square minus 2y square equal to 0, or x equal to we get y. And so from this we get x equal to y. And 7 minus 8, this is 2y square minus 2z square equal to 0, and y equal to we get z. This will be cancelled, y equal to z. We get actually plus minus x plus minus y, but our requirement is minimum value. So we consider the positive value. I left the negative because find the minimum value of this. Minimum given, minimum means we consider positive value. Therefore, from this we get what we get, x equal to y equal to z. These three are equal. And putting these three in equation number 2, 2 implies xyz equal to a cube, and we consider x a cube, then y and z, all of this we putting x, then x cube equal to a cube, then x equal to a. If x, a, all of these are equal, therefore we get y equal to a, z equal to a. Then all of this we get a. Therefore x equal to a, y equal to a, z equal to a. Putting this value in the main function, now 1 implies in 1 f of x, y, z equal to x square plus y square plus z square, and therefore a comma a we get a square plus a square plus a square. This is 3a square. This is the required, which is the required minimum value. This is the required minimum value. Find the minimum value. This is the required minimum. Minimum value is 3a square. Very nice solution, very easy, very simple. Consider another problem of the same types. Find the point upon the plane ax plus by plus cz equal to p at which the function f equal to x square plus y square z square has a minimum value, and find this minimum f. Now solution, this is function given, solution here f equal to x square plus y square plus z square. This is number 1 we consider. Let phi equal to ax plus by plus cz minus p equal to 0. This is we consider phi. By Lagrange method, we have del f del x lambda del phi del x equal to 0, del f del y lambda del phi del y equal to 0, del f del z lambda del phi del z equal to 0. We get this as 0, and putting the value, now first putting del x f. F means x square plus y square plus z square lambda del x phi. Phi means ax plus by plus cz minus p equal to 0. And this implies twice x plus 0 plus 0 plus lambda a into 1 plus 0 minus 0 equal to 0, and this implies twice x plus a lambda equal to 0. We get this is number 3 and this is number 2. We get this one. Next consider this one, del y f means x square plus y square plus z square, lambda del y phi means ax plus by plus cz minus p equal to 0, and this implies 0 plus twice y plus 0 lambda 0 plus b into 1 plus 0 minus 0 equal to 0. 2y plus b lambda equal to 0. This is number 4 we consider. And the last equation is del f del z. Del z f x square plus y square plus z square plus lambda del z phi means ax plus by plus cz minus p equal to 0, and we differentiate partially with respect to z, then x0 y0 z square means twice z, lambda 0 plus c into 1 minus 0 equal to 0. We get this, and 2z plus lambda c equal to 0. This is number 5 we consider. Now we want to solve one by one. Now first we consider 3. Now 3 implies, in 3 we get twice x equal to a lambda and x equal to a lambda by 2. We get value of x. And 4 implies twice y equal to minus b lambda and y equal to minus b lambda by 2. 5 implies twice z equal to minus lambda c or z equal to minus c lambda by 2. We get the values of x, y, z. X is a lambda by 2, y is b lambda by 2, and z is minus c lambda by 2. These 3 values we putting in equation number 2. Since ax plus by plus cz equal to p from this is p, and putting the value of x means minus a lambda by 2, y means minus b lambda by 2, and z means minus c lambda by 2, this equal to p. And this will be lambda common, then minus lambda common, we get a square by 2, b square by 2, c square by 2, this equal to p we get. So this implies a minus taking right hand side, a square plus b square plus c square by 2 equal to minus p, and lambda equal to minus twice p by a square plus b square plus c square. We get this is the value of lambda. Now we can find value of x, y, and z. X equal to, since x equal to minus a by 2 lambda, and putting the value of lambda is minus twice p by a square plus b square plus c square, then this is 2 cancel, ap by a square plus b square plus c square. This is the value of x. Now y y equal to minus b by 2 lambda. b by 2 lambda is minus twice p by a square plus b square plus c square. We get this one, and 2 cancel. We get bp by a square plus b square plus c square. This is the value of y. And z, since z equal to minus c by 2 lambda, c by 2 lambda means minus twice p by a square plus b square plus c square, and 2 cancel. We get cp by a square plus b square plus c square. We get this is the value of z. X, y, z, we get x is ap by a square plus b square plus c square, y is bp by a square plus b square plus c square, and z is cp by a square plus b square plus c square. Putting this value in equation number 1, we get the required minimum value. Minimum value of f equal to this, x square plus y square plus z square. This is our f. X means we know ap by a square plus b square plus c square, and y means bp by a square plus b square plus c square, and z means cp by a square plus b square plus c square, this whole square, and this will be a square p square, and by a square plus b square plus c square whole square. This is b square p square by a square plus b square plus c square whole square, c square p square by a square plus b square plus c square whole square, and this LCM is a square plus b square plus c square whole square, and we get a square p square b square p square c square p square. We get this. So from this, taking p square is common, we get a square plus b square plus c square, and denominator is a square plus b square plus c square whole square, and this and whole square cancel. We get f equal to p square by a square plus b square plus c square. This is the minimum value. Minimum value is, this is the minimum value, p square by a square plus b square plus c square. Very easy solution. Just you have to find lambda, we have to find x, y, z. Ultimately we get our result. So here given this is find the point upon the plane this at which the function this has a minimum value, and find the minimum value. The minimum value is this, and point is x, y, z value. These are the points, and this is our answer. So dear students, these are very easy, very simple, very interesting, and these are, we get any BTech courses, it may be first semester, second, third semester, and we get this type of problems, and PhD major also, mathematics major also, we get this type of problem. So for getting interest, and if you are enjoying with me, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.